Now we're going to look at an autonomous task called the line follower. And if you recall with autonomy, when we create an autonomous program, the primary goal is to accomplish a task. So we have to have something that we're trying to do. So what we're going to do is we'll say that our robot is going to be programmed to carry something. Okay, so let's just say it's carrying mail, for example, around an office building. And what we're going to do is we're going to create a black line on a white surface, and we'll put some turns in there so it always isn't a straight line. And then what we're going to do is we're going to create a program that will have the robot follow the line. And then if an obstacle is detected, the robot will stop and wait for the object to be removed. Okay, so if you think about this, we're going to come along and let's get a thicker one here. So we're going to do something like this, where we draw this line on the ground, we draw this thing, and then then what we're going to do is our robot will come along here, and it's right here. And what it's going to do is it is going to have a light sensor that is going to look down, and it is going to detect the line. And then what it'll do is it'll just move along, and it'll just continue to move until it reaches some obstacle. Okay, so then let's say that the obstacle is right here. And what we'll do is we'll say, okay, so now there's an obstacle. So the robot will come up and it will stop. Okay, so it'll stop right there. So you say, well, what kind of a task would this be? I mean, why would you ever do this? So imagine you're in an office building or a school or something, and you want mail to be delivered from the front office into every classroom. So somebody puts a piece of black tape down all around the school or the office building, and it goes into everybody's office or everybody's room, and it comes up right by the desk. And so then everybody puts an obstacle next to their desk, and what that does is the robot will come along, the mail is put on the robot goes into your office, and then it stops right by your desk. And then you reach down, grab the mail from it, and then you remove the obstacle, and the robot continues on its way. So this robot is just circulating throughout everybody's office, and it always stops whenever it sees this obstacle. So you just so that's an example of delivering mail to everybody in your at school or at your company. Okay, so what we need to do is we are going to detect the line using a line follower algorithm, and then we're going to use the light sensor for that. And then what we'll do to detect objects is we will use the ultrasound sensor. Okay, so let's take a look at a simple line follower algorithm. Now, when you do a line follower algorithm, you're actually not detecting the line itself. What you're detecting is the transition between the edge. You're detecting the dark region and the white region. So you're detecting this right here. You're detecting this transition. And you think about that, that's what the light sensor is really good at. It's good at detecting contrast in colors. So a dark color over here, light color over here. So the most simple algorithm that you can do for a line follower is to put a switch and to say, if I'm ever over in this region, if I'm over here in this region, I'm going to turn slightly to the left. Okay, so if I see white, I'm going to turn to the left. And then if I get into this region and I see dark, I'm going to turn to the right slightly. And then if I come over here, I'm in the white, so I'm going to turn left. And then I'm going to see dark, so I turn right. And then I'm going to see white, so I turn left. And you just go back and forth across this transition. So you can tell that it might seem a little jerky, but what you can do is you can adjust settings such as the motor speed and the angle of your turns, and you can dial it in for basically the course that you're trying to follow. And you can keep it kind of pretty close to following the transition of this line. Okay, so let's take a look at how we would do this. So let's go ahead and bring up our Mindstorm software, and you'll see here that I've got my taskbot, but I've also created a new course. So I have this course where I've put some turns in here. So I'm going to have this line that I'm going to follow, and I will come around here, and it's got different turns in there, and we'll see if we can do this. So let's start by doing the line follower algorithm. So I'm going to go ahead and say line follower 1. And I'm going to come in here, and the first thing I'm going to do is I'll go ahead and put my loop structure down. So I'll go ahead and pop that baby down, and then what I'm going to do is let that loop forever. Now I'm going to put a switch in here, and we're going to add in the ultrasonic sensor in a minute, but let's go ahead and just get the line follower working. So I'm going to take this and I'm going to come down here and I'm going to turn it onto the light sensor. And remember that our light sensor is connected to port 2 of our taskbot. And what we're going to do is we'll just keep it right in the middle, so we have 2 paths within the switch. One when it sees the light, and one when it sees the dark. Okay. So all I'm going to do is I'm going to put a move block in here. So if I see white, what I'm going to do is I will want my taskbot to turn slightly to the left. And let's make it pretty slow when we do this. So I'm going to come down here and I'm going to do unlimited on the motors, because we saw that that kind of helps it not be as jerky. And let's set the motor power to something like 40. Okay, so it's going to go slow, so we can kind of watch what's happening here. And we are going to turn to the left when we see this. So we're going to come along and we are going to set this thing to turn left. And I'll go ahead and do about right there, and we'll see how this works. And so then now if I'm in the zone where I see a dark, okay, if I see the dark, that means that I've moved into the line and I want to transition back, so I want to turn right. So I'll take that same motor and I'll come over here. Okay, so there is our line follower algorithm. It's very simple, and it jerks around a little bit, so so let's just see if this works. So I'm going to come over here, I'm going to grab my testbot, I'll fire this up, and I will program it, and let's just see how well this works. So I download. Alright, so here I go. So I'm going to come over here and I will start it right about there, and I'm going to make sure my wobble wheel is in the right spot, and here I go. So I hit go. Okay, notice it goes left and then right, left and right, left and right, and it's moving left and right. And notice what happened. It followed the line right here, but it was going just a little bit too fast. It couldn't take that right-hand turn because the turn was a little bit sharper. So what we need to do is let's adjust our turning angle, or we can slow it down a little bit so it doesn't go so fast and blow through that turn. So let's go ahead and reprogram it. And let's just slow it down, because I think those turns are probably pretty accurate. So I'm going to go down here and I'm going to go to here and I'm going to slow it down 25, and then I'll slow this to 25. And there's no hurry here. I mean, this is a robot, so we'll just let it kind of work all day delivering mail for us. So I turn these both to 25, and let's go ahead and see if that works. So here we go. Get my taskbot right at the starting spot and go. Okay, now it's going really slow. So here it comes. You can see it going back and forth or along the transition of that line. Here comes the right-hand turn. It was able to make it. Going along, going along. Now can it make the left-hand turn? So it's going on the left-hand turn. Left, 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 left. And it's got one more left to go. And let's see if it comes back. And here it comes. Oh, hit another dark. So we did it. It is following the line. So we actually were able to get the line follower working. Okay, great. And that's it. And you can play with dialing it in, and you can take advantage of knowing the course too. So if you have a course that you're always turning, it's like you're always turning left or something, you can change the left turn and the right turn settings to have one turn more powerful than the other in order to guarantee that you make the turn. And then the other thing you notice is you saw that thing going back and forth. So you saw it wobbling back and forth. One of the things to think about is that the program works. Okay, that's a simple line follower. But this mechanical design is actually really poor for a line follower application. And it's because the turns are accomplished with the rear wheels. But when you do a turn on the rear wheel, if you think about what motion results at the sensor, just a small amount of turn on the wheels results in a large amount of turn at the sensor. So it's highly sensitive. I would say it's oversensitive. So one of the things you could do is you could take this mechanical design and actually redesign it and try to put the sensor really close to where the turn is being initiated. So if you look at really good line follower robots, you'll see that they typically have the light sensor really close to where the wheels are, and then they're really crisp and it doesn't jerk back and forth as much. So that's an example of actually modifying the mechanical design and running the same program in order to accomplish what you want to do. Okay, now we need to detect an obstacle. So I'm going to go ahead and now create another switch within this program to handle if I see an obstacle. So what I'm going to do is I'm going to come in here and put another switch, and I'm going to do it first. So I'm going to have a switch here that is going to be based off of the ultrasonic sensor, and remember that our sensor is on port 1. And what I want to do is let's go ahead and let's change to centimeters and do our 20 centimeters again. Okay, so I'm going to go 20 centimeters when I detect an object. Okay, so if I see the object, what I want to do is I want to stop. So I'm going to go ahead and I always like these sounds in there so I know exactly what's happening in the program. And I'll go ahead and say if I see an object, I'm going to play a tone and just play a little bit. You don't have to wait for completion. But what I really want to do is stop. So I'm going to go ahead and grab another motion block and I'm going to program it to stop. Okay. So now we're sitting here and I come through. First thing I do in my program is I check to see if there's an object. If there is an object, I play a tone and I stop. If there isn't an object, what I want to do is I want to perform the line follower task. So I'm actually going to grab this other switch and I'm going to drag it inside of the ultrasonic switch. So now what I have is I have a nested decision in there, and that's perfectly legal. That's perfectly fine. I'm going to hit pan up here so you can see the whole program. That's perfectly legal to do, and this becomes a pretty complicated program actually at this point because I have multiple paths here. So let's take a look at if this will work. So the line follower algorithm was already debugged, so it should be able to continue to run. So I download this and I'll go ahead and fire off the line follower. Okay, so it's going, and what I'm going to do is I'm going to take an obstacle and see if it sees it. It sees it. So it plays the tone and it stops. So this would be the example of this is the robot comes up to your desk, you have your little obstacle in the way, you say, oh, it's playing a tone, the mail must be here. So you reach down, you grab your mail off the robot, say, okay, go ahead and go to the next classroom. So then the robot follows the line into the next classroom and until it sees the next obstacle, and then what it does is the next person grabs the mail and off it goes. Now notice that didn't take the left-hand turn very well. So what we could do is we could dial in some different settings on there. So let's see if it does it this time. Remember, one of the problems with running the motors really slow is it just doesn't have a lot of control on there. Another thing, yeah, so there we go. I might want to bump that up to maybe 30 and see if it'll be, because it looks like it just, when it goes to take that turn, it's just having a lot of trouble getting that left-hand turn. It's also seeing I have a dark piece under here underneath this white piece right here, and it's actually seeing that. So let's see. Yeah, it's starting to see this dark piece under there. So you can kind of dial in these settings in order to make it robust. So here's what I'm going to do. So since I know it's struggling with that left-hand turn, I'm going to come in here and say when you see light, I'm going to crank that up just a little bit. Okay, so I'm going to make it go a little bit sharper, and I'm going to pump the power up on both of them so that it isn't as sensitive to these little things, and hopefully it blows through all these little corners here. So let's go ahead and download this. Okay, let's see how this works. So now we have our line follower, and here we go. A little bit faster. Its left-hand turns are a little bit sharper, so now we kind of hope that it can make the right-hand turn, and so it did. Good. Now can it take that sharp left? So it's left, 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 left. Perfect, perfect, perfect. And then obstacle keeps going, and we did it. Okay, we have created, it's very simple, but we've created an autonomous robot. The task it's performing is delivering something. We've created a black course all throughout our school or office building, and everybody knows that they are supposed to have an obstacle next to their desk on the floor, and when the robot walks up to it, or when the robot approaches that obstacle, it stops and beeps. You reach down, grab your mail, remove the obstacle, and it's off to the next classroom. So we have done it. We have created an autonomous task. So this is great. So what does this mean, though, when we talk about what we're learning? Well, the first thing is we are now have two medium-sized check marks next to autonomy, which means we're done with autonomy. We know what autonomy is, and we have some examples, some very common examples of how to use autonomy or program the robot to do some pretty simple tasks. And now what we want to do is we want to end this course by looking at a robot challenge, and that's where we'll bring everything together and allow you to get experience actually designing a more complicated robot and program in order to accomplish something very fun and exciting. So that's it.